Hello everyone. So it's been a while since I recorded a new video, and this topic will be on vectors. Okay, so I understand that there's vector 1, 2, and 3, and I'm not going to cover every details. I just go my job here in this channel is really to organize thoughts and make learning easier. And break down traditional model of pedagogy lah. Okay, so I never prepare anything. I just read. Most of the time I go with the flow, freestyle. So if that doesn't roll with you, then you can don't watch this video. Okay, so let's begin. Okay, so how I would organize this chapter, and that is how you should organize, like to categorize what you are learning. Okay, first thing, very simple, distance, angle, okay, and intersection. Okay, that's about it. Okay, there will be times that you are asked unknown. Okay, but then unknown is about forming an equation, and the equation a lot of time depends on the distance or the angle that they provide. Okay, so of course there's other stuff like collinearity, those kind of thing lah. Properties, the vectors, algebraic manipulation lah. Okay, yeah, that one is important. So do spend time on that. Okay, so it's very difficult for me to discuss those questions without questions. Okay, so I will skip that in this video and I will just focus on this three part. Okay, so distance, right, there's really only one thing that I store in my mind. Okay, and that one thing, right, is like that, like that, like that. Okay, so there's a reason why I draw this instead of draw this. Okay, me drawing this, right, is I want to simplify. I want to signify? I want to show that this is a unit vector. Okay, so as a result, right, over here, okay, it will be a dot b like this. Okay, whereas here will be a cross b like this. Okay, so intuitively, okay, it can only be dot or cross. So if you don't know, right, know that this dot is associated with cosine. Okay, whereas this cross is associated with sine. Okay, the derivation, I think I won't cover it today lah. Okay, so if you guys feel that you still work on it on your own, but if you guys think that you still need help, then you can always see me out for tuitions. Yeah, so I will leave my contact below the videos. Okay, so that's the only thing I memorize for distance. Okay, so now the question can be asked like this. Okay, between a dot and a line. Okay, the shortest distance. Actually, it's very simple, right? Dot, point, line. Point cannot be, it won't be perpendicular distance or projection, right? So it's either point and line, line and line, point and plane. Sorry. Point and plane, line and plane. And there's no plane and plane for projection. Shorter distance, okay, shorter distance. But these two planes will be parallel. Yeah. Okay, else is that doesn't, can you be, let me think. Yeah, projection can't be plane and plane. Okay, so let's start with point in line. Okay, point in line is only just this perpendicular distance or shortest distance. Okay, so as a result, I will find, usually you are given a point on the line and the direction, right? Okay, so and then you need to find the shorter distance from this point. Okay, so this is given, this is given. Okay, so just use this distance times the cross. Okay, so let's say this they give you this point, say why do I have a B here? Okay, 2, 3, 4. Okay, then here 5, 6, 7. Okay, and then this direction maybe is 1, 1, 1. Okay, so it will just be this one times this one. Okay, which is equals to 5, 6, 7 minus 2, 3, 4. Okay, then after that 3, 3, 3. Okay, then 3, 3, 3. This thing doesn't make sense because okay, so I need to change this. So this one is 8. Okay, so this 4, this 1, this 1, 8. Am I right? 4, sorry. Yeah, 4. Okay, so this is 8. Okay, so and then 3, 3, 4 cross unit vector 1, 1, 1. Okay, 1 square plus 1 square plus 1 square. Okay, so that's it. Okay, so if line and line, right? Why am I going through this, right? Is because like sometimes students get confused between like why certain times projection, right? They just no offense, but most of the student they just try to link projection to like this straight away, okay, and shortest distance, okay, to this one straight away, okay. But then that at later part, because of this different scenario, right, you will see different. You will sometimes see that, how come suddenly projection, right, it become a cross. Okay, that's why when I saw this problem, I know that I cannot memorize or I cannot orientate my thought this way. Okay, and I found that this the most reliable for me. Okay, so anyway, line and line, right? Okay, you got this line, you got a point. Okay, so line and line, they doesn't make sense for them to ask you for shortest distance between two line unless it's parallel line. Okay, so yeah, okay, because shortest distance, what's the shortest distance? Is it this? Is it this? Is it this? Is it this? Okay, so it doesn't make sense. Okay, so okay, projection. Okay, so projection, right, is just the direction vector of this times the unit vector of this. Okay, that is all. And now, so I don't have to show you everything. Okay, just give yourself example and move here. Okay, so over here is a bit different. Okay, over here, right, is more of you need this. They will give you 2 points, right? So any 2 point will do. Okay, as in use the 2 point that they give you lah. But this way you can use any point on the line. Okay, theoretically. Okay, so over here, right, some student will ask, oh, then this one is it cross or dot? Okay, cross or dot depends on what the question gives you. Okay, so in this case, the question gives you this direction, right? So you find find the direction of these two vectors. Then after that, do the dot product of the direction vector law. Then you will get sorry, do cross product with the direction vector. Okay, so you want to find here, so you will do this one cross this one. Okay, can. So let's say if you really know this direction, right? Okay, it's also okay. You can just do dot product. Okay, unit vector. Okay, so it's situational. Yeah, but I can safely say I can say this one makes sense because usually if you are given a line, you are given the direction. Okay, I'm just saying that fundamentally both is correct as long as you know the direction. Okay, fundamentally is correct. Okay, so line and line finish already, point and line finish already, and that's how you should like make organize your stuff to make sure you cover all grounds. Okay, next up, point and plane. Okay, so over here, right, you always need that I call it the hypotenuse, okay, and then after that you go and find the unit vector from the adjacent or from the opposite, okay. So when you are given a plane, given a plane, okay, means the question say okay, you will have the point, okay. Even if you don't have the point, say they give you like that 1 2 3, right, okay, equals 7, then you go ahead and make 1 point, okay. So your point here can be 700, okay, or it can be here, say 0 to 1, okay. So both point will lies inside this plane, okay. When you substitute in, it satisfies means it lies inside. Okay, so what I want to say, right, is that although, okay, in 2-dimension, let's say this is a point, okay, like the horizontal distance doesn't, the shortest distance, right, doesn't look the same, okay, but in 3D plane, right, it's the same, okay. Imagine this, okay, if I got a point here and any point here, okay, this and this, okay, then after that I take the horizontal, right, okay, it's going to produce this length, okay, even, yeah, so this point and this point going to produce this length, okay, any point here and this point is going to produce this length, okay. That means to say you can use any point, okay. So I don't want you to think of to look at diagram this way, like that. No, it's not a 2-dimensional thing. Then this one you think that the distance is this. No. Okay, so start to see things in 3 dimension. Okay. So what's next? Oh yeah. Okay. So you got this point because definitely they will say, oh, the shorter distance from a point to the plane. Okay, then after that you got this point, and you go and find one point. Okay, join two of them together. Okay, then what you have, whether you have this direction or this direction, right? Okay, so you got this direction, okay. So like I say, right, remember this one, like that is dot, like that is cross. Okay, this is dot, this is cross. I just reorientate this thing. Okay, that's all. Okay, so do get familiarize yourself with this thing. Okay, where is the dot and where is the cross? Okay, as in, yeah, when you want to find projection, you should you dot or should you cross? Okay, then yeah, and then rotate it around. Maybe yeah, draw like this. Yeah, and this thing can be here, then can be here, then what's the implication, etc. Okay. Okay, so yeah, okay. So over here, right, the only information we have about the direction now is this direction. Okay. While you can find the shorter distance, okay, by using here, but you don't know what is this direction. Okay, you don't know. Okay, so over here is 1, 2, 3. Okay, then you won't be, if you got this 1, 2, 3, right? Okay, you won't exactly know what is this direction. Yeah, because you just never, we just never learn how to. Okay, yeah. Okay, so the other thing is it has to be very particular. It has to be this direction. Okay, it cannot be this direction. It cannot be any other direction. Okay, so even you have 2 points, right? Okay, it doesn't mean that you can just use that 2 point and make it uh, uh, the unit vector. Okay, why is that so? This requires a bit of your imagination. Okay, imagine I got a point here. Okay, then I got a line here, a point here. Sorry. Okay, just use this example. Okay, so if you just take, because sometimes they can confuse you with, okay, r equals to something plus lambda 567, then 576, okay, and then plus mu say 816. Okay, example. Okay, then student might just use this because they think that, okay, this one is this direction. Okay, but there's no guarantee. This can be in any direction as long as it's parallel to the plane. Okay, so why I say that that is wrong, right, is because that doesn't give you the perpendicular distance. In fact, right, that gives you this, instead of the drawing the line straight down, right? Okay, this one is drawing the line diagonally down. Okay, instead of like this, right? Okay, it becomes like that. Okay, that's why that is not the shortest distance. Okay, that's why very particularly you need to use this. Okay, so it become this direction dot this direction. Okay, which was what I mentioned here. So now this shorter distance become this shorter distance become a dot b. Okay, that's where the confusion start to come in now. How come I thought shortest distance is cross? Okay, it really depends. Okay, on whether is it plane or is it line. Okay, and what are the information you are given. Okay, yeah. If you guys want to form certain method of memorizing, right, or certain defaults okay, you need to prove it for all scenario first, then you can rely on that. Okay, if you cannot form that basis, right, that is fundamentally correct for every scenario, then don't move on. Okay, come up with something again, come up with something again. Okay, so this is just how I do it. Okay. Okay, so next up, line and plane. Okay, line and plane again doesn't make sense to have to have shortest distance. Okay, so it can only be projection. Okay, so this one and this one, to find here you need to cross. Okay, that's why now projection it becomes this thing. Okay, so yeah, so like I said again okay, just reason out based on this fundamental. Okay, you could only get it wrong if your adjacent or your opposite, right, you choose the wrong vectors. Okay, that require your visualization a bit. Okay, why this one like that? cross, then I don't get the projection, or cross, I don't get the shortest distance. Okay, and your awareness of the information in the questions. Okay, so for example, you need to be very clear that your number is in this direction now. Okay, like be good with drawing diagram and orientation. Okay, so line and plane finish already. Next up, plane and plane. Okay, I'm talking about plane and plane that are perpendicular. Okay, so plane and plane that is not perpendicular, right? Doesn't make sense to have a shortest distance, or doesn't make sense to have a length of projection. Okay, so this one, we know that, let's say, okay, r dot 111 equals to 2, and sorry for the messiness, okay, but yeah, you can always pause and reverse the video and organize it on your notes that you are taking. Okay, so okay, r dot 111 2 and r dot 111 and 3. Okay, so we know that, right, r is this point, any point, okay, any point on the plane. Okay, 111 is a normal, okay. So this 111 right there, 111, if it's a unit vector, okay, r is a position vector, position vector means that it starts from, okay, sorry, this 111 is in this direction, okay, then r is a position vector, position vector means it starts from origin, okay. So if like that, then we change this 111 to a unit vector, right? We do a dot product, we're gonna get this. So you see this one, origin to the point, then dot product, then like that, is something like this thing. It's something like this thing. Okay, so if we r dot 1 square root 3, we get 111, then we will get 3 over square root 3, so it's square root 3. Okay, so this will be the distance from origin to the origin to the plane. Okay, whereas this one, right, will be the distance from the origin, origin to the other plane. Okay, so you minus both of them together, then so just now it's 3 square root 3, 3 square root 3 minus 3 over square root 3, right? Let me think. Yeah, minus 2 over square root 3. Okay, then you get 1 over square root 3, which is square root 3 over 3. Okay, so that would be the distance between two planes. Okay, so with that, we are done with distance. Okay, next up, we will talk about angles. Yeah. Okay, so try to recall, right, when is the first time you saw angles being introduced in this chapter? Okay, it is when A dot B, right, you are given the definition of A dot B and A cross B. Okay, so A dot B, right, is equals to A dot modulus times B modulus and cosine theta, where theta is the converging or diverging angle between the two vectors. Okay, then here is mod A times mod B times sine theta, and then a unit vector that is perpendicular to A and B. Okay, which makes sense because this one is a vector. Okay, so overall here is a scalar ma. Okay, so you need to have one more vector to make it a vector. If it's too technical, right, just think of like that, like that, like that. Left hand side is like that, the right hand side is some number, so you need to times one more like that. Okay, and you try to keep it as simple as possible. Okay, and once you keep it as simple as possible already, then you will be able to talk about complicated stuff naturally. Okay. Okay, so on top it will be scalar lah. Okay, that one don't have to explain. Okay, so yeah, so that's the first time that you seen angle. Okay, so this theta, right? Okay, because it's a cosine ma, so try to relate to cosine graph. Okay, then after that, draw a few examples of your A and B. Okay, so A and B can be like this. I'm drawing in diverging okay, so it will represent the same as converging okay, so I just draw everything diverging. Okay, so this angle, it can be like this. Okay, so that should cover all the quadrant okay, because this one is less than 90, so first quadrant. Okay, then after that, this one more than 90, less than 180, second quadrant. After that, this one more than 180, less than 270, so third quadrant. Then this one fourth quadrant because more than 270, less than 360. Okay, so this will cover every scenario. Okay, so that means to say, right, okay, our cosine theta, which is y value, okay, will be mod A times mod B. Then, sorry, the cosine value, because the mod A, okay, mod A and mod B will be positive ma, okay? So in this case, cosine obtuse, right, means 90 to 180, right? Okay, will be negative. Okay, whereas this one will be positive. Okay, because cosine theta is positive, mod A mod B is positive. Okay, can so this will be able to help you to measure acute or obtuse angle. Okay, I'm saying all this because sometimes students don't know when to use mod and when not to use mod. Okay, so when they just ask for the angle, right, without saying obtuse or acute, okay, just use this one without modding it. Okay, so next up, let's talk about this thing. Okay, so over here, right, the thing is you will only um be able to calculate sine once you mod this. Okay, and the other thing, right, is that this and this, right, will be in the same direction already. Okay, so if they are in the same direction, right, this thing definitely have to be positive. I'm saying if this one A cross B, the resultant is upwards, the unit vector is upwards, okay, sine theta definitely will be positive. Else it will turn the direction downwards. Okay, so if you think about it, okay, theta is the angle between the two vectors, right? So the angle between the two vectors, right, it can only be 90 to 180 ma. So definitely, no matter what you put, right, okay, your this one is gonna be positive. Okay, so this is gonna be positive. Okay, so be it just like this or be it after you mod it, you need to mod it because in order to calculate the sign, you need to change everything to scalar. Okay, so if you change everything will be in positive. So your theta will be positive. Okay, so it cannot really reflect. So your once okay, so this like that. Okay, so this one given, then you mod. Okay, overall is positive. Then after that you divide by mod A, divide by mod B, then positive. Okay, so you're gonna have sine theta. Okay, so what I'm trying to say is sine theta, right? Okay, equals to positive, right? Then you don't have a clue on whether this one is it gonna be acute, okay, or obtuse. Okay, you are kind of stuck. Okay, yeah. So if they never ask for acute angle, right? Okay, then you don't know whether you should provide the obtuse angle or the acute angle. Why I say it can be acute or obtuse, right? Firstly is the graph. Secondly is ASTC. Okay, so if it's too complicated, right? In short, this one okay cannot use to find whether is it acute or obtuse. Okay, you can use it okay when the question asks for acute. Okay, and this one okay you can use it to find acute or obtuse. Okay, so if you want to find acute for this one, you need to you can mod everything to make your cosine theta positive. So your theta will be acute. Okay, so if it's too confusing, right, I need you to re-understand and familiarize yourself with the angles, the quadrant, and the sign, as in SIGN. Okay, so I repeat again. Okay, if you want to find acute or obtuse, okay, you can use this. Okay, if you want to find acute, then you mod this thing. Okay, or you don't want also can. Okay, you just find the resultant, and after that the resultant may be an obtuse angle, but they ask for the acute angle. A and B may actually be obtuse angle, but if they ask for acute angle, then just change it to instead of 120, then you say the acute angle will be 60. Okay, then this one can you wouldn't know whether it will, because you wouldn't know whether in actual fact is acute or obtuse. Okay, so if they ask you for acute angle, okay, then okay you have the base angle already, then you just give the acute. If they ask for obtuse, which usually they don't, but if they can still ask, okay, then you change that to the second quadrant. Okay, so yeah, but then don't take it as a hard and fast. Okay, sometimes you need to see what is provided in the question. Okay, if this one is provided in the question, then like they say A cross B, they never give you the vectors of A and the vectors of B. They just give you the magnitude of A, magnitude of B, and the resultant at A cross B. Okay, then you have to use the sign. Then they will provide further information for you to, or whether the find the second quadrant or first quadrant. Okay, so with that, we are done with and I won't want to say we are done with anger, because obviously it's deeper than that. But I will leave it to you guys to think of the different scenario lah. Okay, like this one and this one. Okay, then now what is the A and B? Okay, then line and line, now what is the A and B? Okay, okay, let's do it together. Okay, so if this one is direction 1, this one is direction 2. Okay, so the angle between two line will be this one. So do know that I'm using direction okay, because imagine this direction and this direction, right? Okay, then the line will be like that. Okay, so it's the same thing. Okay, it's the same as this. Yeah, okay, so yeah, so just like that, d2 like that, divided by mod d1 mod d2 equals cosine theta. Okay, so depends on this one whether, because imagine dot this one times this one, this one times this one, this one times this one, overall add up together, it can be positive or negative, right? So yeah, just see whether this one positive or negative. Okay, then you will know whether your A and B emerging or converging or diverging is pure or obtuse. Okay, next up, this line and plane. Then after that, you got plane and plane. Oh, okay. So okay, so yeah, okay. So let's talk about the line and plane first. This is very interesting. Later, we we will have a quite fruitful um, discussion. Okay, so this thing, right, is direction 1. Okay, then you have normal vector. Okay, so by right, okay, if you just use the most basic definition, right, you are looking for the angle here, right? Looking for the angle here. Okay, but that is not what the question is asking, because the question will normally ask line and plane, angle between line and plane, right? Okay, that's why you can do this. Cosine alpha equals to delta 1 dot n over delta 1 dot delta dot n. Okay, or then after that, no, now this alpha is not it's the angle between the normal and the direction. It's not the angle between the line and the plane. So to find the angle between the line and plane, you need to you need to 90 minus this thing, okay, which is equal to this. Okay, so in some text, right? Okay, in some lecture notes, okay, they will straight away like write this. Okay, this is true. Okay, then now you are able to include theta into an equation, so you can find theta, where theta represent this. Okay, why is that so? It is because cosine alpha is equal to sine 90 minus alpha. Okay, so what do I mean by that? If you got this angle and this angle, I think it's called supplementary or complementary. I think it's supplementary angle. Okay, so sine of this one is this over this. Cosine of this one is this over this. So they produce the same ratio. So they are the same. Okay, opposite over hypotenuse and adjacent over hypotenuse, that opposite and adjacent, because that angle, the foundation of the angle, okay, that's why the opposite and adjacent are the same side. Okay, that's why the sine theta and cosine alpha and sine 90 minus theta and sine 90 minus alpha is the same. So that means that complementary angle, okay, sine complementary, yeah, okay, you get what I mean. Okay, so that's it for angle. Wait, okay, now let's talk about plane and plane. Okay, plane and plane, some people will think that how come this one, then what's the angle you are talking about, right? Okay, but if I draw the plane, right, to be just like this and like this, okay, so you need to imagine, it's not, if the plane is like that, okay, into the screen, okay, and into a screen, okay. So you will be able to know that, oh, the angle I'm talking about, right, is this, okay. So what I'm trying to say, right, is that any plane, right, can be viewed like this, okay. Why I say so? It is because, right, this plane here, right, it doesn't necessarily have to be this shape, okay. Try to understand now. R dot 1 2 3 equals to 1, right? Okay, this x doesn't need to be kept, okay. This y doesn't need to be kept. I'm trying to say is this thing can be 100 or 1000 or 1 million, okay. Then you just need to find, say here, minus 33, okay. That means to say, right, okay, this thing, right, is endless, okay. It can be this big, etc., at least in your syllabus, okay. There's no bound of x and y, okay. That means, right, I can draw this um plane, right, as I'm talking about this plane, okay. I can draw it like this, right. They are still lying on the same plane, understand? Like this one and like that is the same plane, okay. You draw one circle also the same plane, okay. So if now you look at this from this angle, right, okay, it will be like that, lor. Okay, so long story short, okay, there will be a normal here, okay, there will be a normal here, okay. So you do the, what's that called, the something dot something, right, because obviously you're gonna use cosine, right, because if you use sine you need to do cross product, okay. Then you find this angle, okay. Then after that, this one 90 degree, this one 90 degree, so 180 minus 50, then you will be able to find the angle here. Okay, so yeah, that's all. So if you want to keep it simple, you need to be very good with drawing graph, yeah, drawing diagram. Okay, next up we talk about intersection. Okay, on intersection, again, same old thing. Point and line, point and, yeah, okay, line and line, point and plane, line and plane, plane and plane. Okay, so point and line, right, it just mean whether it lies inside the line, okay. Then point and plane also whether it lies inside, lah. So I feel that, right, a very big part of intersection, right, is really do you understand what's the definition of vector equation of a, or equation of a plane and equation of a line, okay. Which kind of ties to whether do you really understand the meaning of equation of straight line, equation of just equation, okay. What I'm trying to say, right, is that, okay, this one is r bracket, for example, a line plus lambda 456. Okay, so this is what do these really mean? Okay, when you want to represent a graphical um, road lah, okay, or a connected points, etc., right, or a set of related uh, points, is, yeah, so you see it's related points, okay. That means to say you need to be able to express all the coordinates in the equation. Okay, what I'm trying to say is that this one is got one combination is 5 7 9, okay, which is this one. Okay, then got the other combination, right, is 9 12 15. The other combination is 1 2 3, etc. Okay, so all these, right, is sort of could be a possibility of this xyz. Okay, so this xyz is going to represent all the points. I say it again, this xyz is going to represent all the points. Why I keep emphasizing this, right? It is because a lot of times finding intersection, right, is about finding that xyz, is about finding that point. Okay, sometimes that intersection, right, can be a line, for example, plane and plane. Okay, yeah, but that is representing xyz in a manner, yeah, that symbolize a lot of points. Okay, so just keep it as, okay, xyz for now. It represent a lot of different points. Okay, so finding the intersection of line and line, right, is about finding a point that satisfies both line. Okay, that's why when they say, okay, lines inside, right, point in line, right, you just need to check whether 576, right, satisfy this whole thing, whether there is a value of lambda that can produce this 579. Okay, okay, so now line and line. Say first equation is this. Okay, second equation is 456 plus lambda 789. Okay, so if you want to find the intersection of them, firstly look at whether they are parallel or not. Okay, that's the most direct way, the most immediate way. Yeah. Okay. Okay. Second, again, then you think about what I just said. Okay, ultimately they are just, intersection is just a point. Okay, so that represent that this point, right, satisfy 456 plus 7 lambda plus 8 lambda plus 9 lambda. Okay, the point also satisfy 1 plus 4 lambda, 2 plus 5 lambda, 3 plus 6 lambda. Get what I mean? Like over here, all these got different lambda. Okay, at here there is some lambda, we don't know what is it. Okay, we don't know yet. Likewise, this way, all these things got different theta. Okay, but then we don't know what is the theta yet. But we know that after substituting the correct lambda and the theta, right, they are going to be the same resultant value. Okay, so now let's look at this more from an algebraic perspective. You got two unknown, three equation. Traditionally, we only need two equation, two unknown to solve for lambda and to solve for the two unknown now. Okay, so with these two, you will have some value of lambda and theta. Okay, so after that, by right, if you have the value, you say that this one is theta is equals to 1, lambda is equals to 2, right? You substitute in based on just now what we mentioned, right, they should be the same. Okay, so if they are not the same, then think of how the two line in 3D orientation can have different possibility. Okay, so in this case, right, it will be is that if it doesn't satisfy the third equation after you sub in the two unknown, it's gonna be a skewed line. Okay, so yeah, that's it for line and line. Okay, next up, let's talk about the equation of a plane. Equation of a plane is r dot 1, 2, 3 equals to say 4, right? So this is going to represent a lot of different points. It can be 4, 0, 0. It can be 1, 0, 1. Can be 0, 2, 0, etc. Okay, or 0 point something, 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 as long as it says 4. So it represents a lot of points. Okay, then you have this as the equation of a line. So we are doing line and plane. So you know that if the line intersect the plane, okay, that the point that of intersection, right, will just be some lambda that we haven't figured out yet. Okay, maybe it's 3, maybe it's 2, we don't know yet. Okay, but putting it inside here is gonna set that value that you put it inside, is gonna give you 4. Okay, that's why you can do like this. Okay, then after that solve for lambda. Okay, of course there will be scenario that, because I said before just now that every different scenario of the possible value you can get from this algebraic manipulation, right, should tally with the 3D scenario. Okay, there could be a scenario that, okay, your maybe here got some negative, etc., right? Okay, then your lambda got eliminated. Okay, so they cancel off each other and you get 0 lambda. Then after that, here you get 5 equals to 4. Okay, in that case, there is no lambda. No matter what 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 you put in, right, because they cancel off each other, there is no lambda that satisfies this equation. Okay, that means it doesn't lie inside the plane. Okay, means all the point doesn't fit inside. You try 1, try 2, try 3. Yeah, so we generally write it as lambda. Okay, whether you try 1, try 2, try 3, it will cancel off each other. Okay, so that means it doesn't lie inside. Okay, so that's it for line and plane. Okay, next up, plane and plane. Plane and plane, plane and plane. The only way that the plane and plane can intersect, okay, is like this. Okay, so it produces a line. It either is on like the above or in the parallel. Okay, so now there is a few method of solving this. Okay, I believe that you guys have seen that usually they will write uh, direction vector of line of intersection equals to n1 cross n2. Okay, why is that so? Okay, try to imagine this book. Okay, the normal okay, this direction and this direction, okay, their normal is gonna be this towards the screen, which is this direction towards the screen. Okay. Um yeah, do your own try it on your own to visualize it 3D. Okay. So no matter how I move this plane and how I move this plane, okay, it just continue. If I like that, okay, like that, okay, this direction and this direction, you cross it, it's still gonna point towards the plane. Okay, so crossing them, right, will give you the direction vector of the intersection. This is the intersection. Again, no matter how I flip it, this is the intersection. Okay, so that's why it's M1 crossing 2. Okay, so to find a vector equation of a line, you need direction and you need a point, right? So how do we find a point? Okay. Let's say one of the plane is this, the other plane is 5, 6, 7, goes to 8. Okay, how do we find a point, right? We can look at it from the Cartesian perspective, okay, where x plus 2y plus 3z equals to 4 and 5x plus 6y plus 7z equals to 8. So just now I mentioned about this concept of three equation, two unknown. Then now is two equation, three unknown. Okay, so if two equation, two unknown, then that's your typical simultaneous equation. Then that is solvable. Okay, in this scenario, it's not solvable yet. But let's say we know a value of we replace a value of z and we replace a value of z, then it is solvable. Okay, so let's say 1, 2, 3 cross 5, 6, 7 equals to example, okay, 1, 1, 0. Example 1, 1, 0. Okay, so vector equation of the line will be equals to something plus lambda 1, 1, 0. Sorry, 0, 1, 1. Okay, so for this scenario, think about it. No matter what value this is it 9, 8, anything, okay? I will be able to have a lambda, right? Okay, that makes this value 0. Be here is 2, 3, etc. I will always have a way to make this 0. That means to say, right, as long as here is some values, right, okay, I will be able to make this 0. That means to say something something 0 will always be a point. Yeah, okay, something something 0 will always be a point. Okay, so over here, right, except okay, there are exceptions, but in this case, there is not always, okay, something something 0 in this case is one of the points. Okay, that means I can substitute z to be 0 to find that x and y of the point that we were referring to. As a result, you will be able to now produce a point and a line and eventually get the direction vector of the line. Okay. So eventually, in summary, right, what we're trying to do, right, okay, is because three unknown, two equation cannot solve. Okay, so we need to substitute one of the value, it become two equation, two unknown. Two equation, two unknown, you can solve for the x and y or y and z and etc. depending what you make to be zero. Okay, so with x and y and zero, it is a point. If it is a point, you got direction, you can form a line. Okay. Forgot what I say. Uh, Yeah, so there are exceptions that you cannot make this to zero, okay, which is when your this direction vector here, the coordinate is zero, okay, one of the point, the coordinate is zero, lah. Okay, one of the elements, okay. So if it's zero, then here may be zero, but it may not be zero. Here may be 5, 6, etc. As long as it's not zero, right, you cannot. Okay, so in general, right, when this is zero, right, you cannot say for sure, okay, there will be a x value that is zero. Okay, get it? So this one is not you just let anything to be zero. It's very situational. You need to see here. Okay, so let's talk about so with it yeah, okay, you know how to find point already. Okay, when can it be zero, when cannot be zero. Sub the zero in, do simultaneous equation, find xy is zero, and after that in the last plus the direction vector give you the line of intersection. Okay, now I want to talk about the using the Cartesian method. Okay, so let's say the Cartesian method, right? Okay, okay, so in this case, right, usually they will say let something equals to lambda. Okay, try to imagine this. Okay, if I have a certain value of this and certain value of this value can be 1, 2, 3, 4, 5, 6, 7, 8, 10, 1, 2, 3, 4, 5, 6, 7, 8, 10, whatever. Okay, as long as I have a value, I would definitely be able to solve this simultaneous equation because two equation, two unknown. Okay, so we try 1, 2, 3, 4, 5, 6, 7, 10. Oh, can solve, can solve, can solve. And all these 1, 2, 3, 4, 5, 6, 7, 8, 10, they produce a respective x and y value. So all these x and y value, you combine them together, is gonna produce you the line. Okay, because they satisfy both equation. And if you satisfy this plane and this plane, okay, then it's gonna form the line of intersection. So do we have to really like do every value? No, right? We can just, because if you do the manipulation, you realize that in the 0.1 and the 0.2, they just move at the same order lah. Okay, so we just keep this as lambda. Keep this as lambda. Okay, so with that, right, think about it. If you solve for simultaneous equation, okay, usually is your x equals to what, and your y equals to what, okay. Say if your sub z equals to 1, z equals to 2, okay, is equal to 5, equals to maybe 8, etc. lah. Okay, but then you realize the manipulation, right, is maybe sometimes it's like that. The other time it will, I mean, lambda is 0.2 is like that, then 0.3 is like that. Okay, so definitely, right, here will be something minus lambda, like that in this form, something plus something lambda. Okay, then can be division, etc. But eventually it will just reorganize. It will just be like this in terms of fraction. Okay, then after that, like that, like that. Okay, z equals to lambda, and with that, okay, you will be able to form the equation of a line. Okay, so like I said before, right? Okay, not anything there's this part of in this idea of okay, not any value can be zero. Okay, so in this context, right? Okay, when you substitute the z, right, you need to be very sensitive of which one you make it lambda. I give you another example. Okay, let's say your equation is something like this. Okay, this is the scenario where you cannot make this to be lambda. Okay, because when you make this to be lambda, right, you are considering solving simultaneous equation of this. Okay, simultaneous of this equation will not give you new information. Okay, because yeah, they are so-called parallel. Okay, it's like me telling you x plus y equals to 5 and x plus 2y 2x, okay, equals to say 10 or maybe 8. Okay, then it's not solvable. Okay, or there's no new information. Okay, so when you do this method, right, you need to look up for those kind of stuff, which is a bit more non-intuitive. Yeah, that's why I still prefer this method lah. Okay, so with that, yeah, that is all for intersection, and that is all for the topic on vectors. Okay, so I hope that it benefit you. So if it do benefit you, yeah, why not share it with your friends? Yeah, okay. So see you in the next lecture. Bye bye.